Modern enterprise networks operate at a continuous volume. Every second, millions of requests and commands flood global infrastructure, pushing system capacity to its limit. For decades, human operators managed this traffic through established workflows. But as the velocity of customer demands accelerates, these manual sorting methods begin to crack under the sheer weight of incoming data. The clearest sign of this failure is the life cycle of a standard support ticket. A customer reports a critical error, and instead of finding a solution, the request bounces from department to department, endlessly reassigned by technicians trying to clear their overloaded queues. This creates a compounding problem. As data moves faster through the network, the loss of precise direction creates exponentially more chaos. The volume of unstructured, complex technical issues eclipses the physical ability of human engineers to manually read, categorize, and route them to the correct desk. To manage this overwhelming load, the technology sector points to artificial intelligence as the definitive answer for automating complex categorization. Yet, the reality of implementing these systems is far from seamless. Cisco executive Liz Centoni noted that the actual process of adopting AI into established enterprise networks is a remarkably painful experience. A global network cannot be turned off for an upgrade. The integration must happen while the data is actively flowing, comparable to performing open surgery without anesthesia on a moving patient. Organizations must rewire their entire operational nervous system while relying heavily on that same system to function daily. The moment an AI routing system goes live within an older, disorganized network architecture, the immediate result is severe internal friction. Organizations enter an implementation chasm, a highly volatile period where the fluid, often ambiguous nature of human workflows collides directly with rigid machine logic. The new model must first ingest millions of historical company records, reading decades of inconsistently logged notes, parsing through fragmented emails, and highly specific technical shorthand. The machine attempts to parse a human logic that was never mathematically standardized, struggling to understand the informal rules employees use to actually get work done. This mistranslation creates an immediate bottleneck. The newly installed AI begins misrouting support tickets at a rate far higher than the old, entirely manual system. Highly specialized engineers suddenly find their dashboards flooded with irrelevant problems. Security experts receive hardware requests, while database managers get password resets. Human operators are forced to step in and manually redirect the machine's mistakes, losing hours of productive time to administrative cleanup. The pain of this phase stems entirely from the friction between a system that requires absolute mathematical certainty and a workforce that operates on nuance and institutional memory. This severe friction highlights Liz Centoni's core inquiry. The challenge is teaching a machine how to accurately identify and communicate with the specific human engineer capable of solving a nuanced problem. When a complex technical support issue enters the newly integrated AI system, it no longer sits in a static queue. The routing model evaluates the technical parameters of the error code against thousands of internal employee profiles, checking past resolution history and specialized skill sets. The algorithm filters out false matches by weighing specific technical identifiers, like API error codes and deployment environments, against the engineer's historical success with those exact parameters. This marks the precise moment of translation. Messy, unstructured human expertise is successfully mapped onto a clear, mathematical neural network. Securing this exact matching process is the mandatory first step before an enterprise can safely expand its operations without overwhelming its workforce. After the painful ingestion and correction phases, the model finally internalizes the complete, authentic organizational map of the company. The erratic, unpredictable routing behavior begins to smooth out, shifting into a highly efficient, continuous flow of incoming information. The system absorbs the administrative burden of reading and sorting data, removing the triage process from human hands entirely. As a result, network architects and software engineers log in to find only the highly specific, complex problems that require their exact set of skills to resolve. The enterprise reaches a state of operational symbiosis, perfectly pairing the sheer processing speed of the machine with the irreplaceable technical expertise of the human operator. Zooming out, the macro view looks completely different. The frantic, broken pathways are replaced by a stable, continuous transfer of data across global infrastructure. The severe friction of those early months was the mandatory toll required to escape a collapsing legacy framework. Successful deployment only happens when an organization is willing to endure the deeply uncomfortable process of strictly defining its own internal logic for a machine. The architecture of the enterprise has shifted. By automating the cognitive labor of sorting, the system ensures that human expertise is applied only where it is essential.